Alright, in this video I'm going to finish up this concept worksheet that we started up in class. Well, I'm going to finish most of it. I might have you do some of it. And the purpose of going through this with you is so that then you can do these problems in the back of your note packet. So we lost another day to the snow day, but our schedule has to keep marching on, so we're going to do this lesson here in video. Oh, I already got some answers written on here. So here, let me erase here so you can see how I got at those answers. Sorry about that, didn't have a blank one at home. Alright, so we have a graph here, and it says let f be the function whose graph is shown at the right, where f is defined between 0 and 2 and has a point of symmetry at 1, 0. So that means it's symmetrical about this point. So this is exactly the same as this. So remember, all this area above the x-axis is positive area and below is negative. And the reason we're talking about area is because then they say let capital F of x be the integral from 0 to x of the function. So capital F of x, think that is a function representing the area between f of x and the x-axis. So the first one says evaluate f of 0. So that's saying what is capital F equal to when x is 0? Well, here's x. X is our upper bound on our integral. So if we were evaluating from 0 to 0, that's an area of 0. We have no area. Next one says what if x is 2? So capital F of 2. So capital F of 2 means x is 2. So I'm going from 0 to 2 of the function. So I'm looking at the area between the curve and the x-axis from 0 to 2. Well, 0 to 1, I have this positive area. I don't know how much it is. But 1 to 0, I have the identical negative area. So remember, the integral will subtract the negative from the positive, so I'd end up with an area of 0 there also. F of x has a maximum value at x equals. So where is the max area is the question we want to be answering here. Well, if I go from 0 to 1, I have all this positive area. The minute I get past x equals 1, I'm into negative area. So the max of this function occurs at x equals 1 because all of the area up to that point is positive. Anything after that I'd be minusing the negative area and it would be a smaller number. Okay, then it says f prime. So now I need to think the derivative of this area function. Well, I think maybe the best way to deal with that is let's sketch on here capital F of x. Okay, so this is f of x. We said that at f of 0, our area is 0. So we're going to put a point there, right? And then we said at f of 2, our area is 0. So we know we have a point here and a point here on our derivative graph. And then we said the max happens at x equals 1. So we're going to have, I'll do this as best as I can, we don't know what that max area is, but we know it's going to happen at 1, and then we're going to go back down to 0. So pretend this is perfectly symmetrical, because it should be perfectly symmetrical, because the f of x is perfectly symmetrical. So this is a sketch of what capital F of x would look like. Now let's see if we can answer this question. F prime of x has a minimum value at x equals. So a minimum value. So we want to think about the derivative of this graph. So it's going to have a derivative of 0 at x equals 1 because we'd have a horizontal tangent here. Between 0 and 1 we're increasing, and then we're 0, and then we're decreasing. So if I were going to draw the derivative capital F prime of x, I would say I'm increasing, So I'm positive, I'm above the x-axis, and then I'm 0, and then I'm going to be below the x-axis. So I can say the minimum value of f prime of x is going to happen at x equals 1/2. I'm assuming we're going to be symmetrical here. Wait a minute. Oh, wait a minute. F prime has a maximum. F prime, my worksheet is wrong here. This should say maximum. I was answering that question for maximum. I think this should be max, this should be min, otherwise these are the same question. So a max would occur at x equals 1/2. I'm 0, I'm increasing at x equals 1, I'm 0 again, so my max would happen at 1/2. So my derivative, my capital F, this is capital F of x, my capital F prime of x would do something like this, 0, and then decreasing. So my max would be here, and my minimum of that graph would be between 1 and 2. So that would be at x equals 3/2. And then f double prime of x would be positive, greater than 0 for what values? Well, remember, double prime or second derivative is our concave up, concave down. Well, our first derivative is concave down here. And so our second derivative, we're going to have greater than 0. Concave up at x is between 0 and 1/2. My first derivative is going to be 0 here. So my second derivative is going to be 0 here. So I'm increasing, decreasing, increasing from here to here. I'm going to be concave up. And then again on the other side between 1.5 and 2, because I'm doing this. So this is my f prime of x. So if I'm thinking of the derivative of that, increasing 0, decreasing 0, increasing. So wherever I'm increasing, I'm concave up. So here and here. And concave down would be wherever I'm decreasing. That's all the way from here to here. I'm decreasing. So that's going to be between 1/2. Oops, that should just be a, there we go. Between 1/2 and 1.5. So draw a rough sketch of the integral function f of x on the graph. Well, that's the one we already drew. So we drew f of x, and we drew f prime of x. Okay, we'll look at the next part briefly too. I'll go through this quickly. Actually, maybe what I'll do on this one is, I'll go through it a little quicker, and then you might want to go back and look at it yourself and see if you understand where I got these answers from. So the graph of an odd function is shown. Once again, capital F is the integral. So, and assume f of a equals f at a equals b. So this is the area at a is equal to b. So this is the f of x, and our capital F is the area under this curve. So here I'm going from negative a to a. So that could be any of these x values, but if you look, I am once again symmetrical. It says I'm an odd function. So if I have negative a to a, I'm going to have negative area and an equal positive area. So my area is going to be 0. Now here, absolute value. Remember, absolute value takes your negative area and makes it positive. So I'm going to have twice this area. And this tells me the area at A is equal to B. So twice B would be 2B. This is negative a to a. Once again, this should have an F outside here. So this has got the f and then the absolute value on the variable here, or the a. Well, it doesn't matter if you absolute value the whole function or if you absolute value the a value or the x value, you're still going to get 2b. And then it says draw a rough sketch of the integral, so sketch the area graph. So we know if you were doing at the 0 point, your area would be 0. And then this is all positive area, and the area here is always increasing. It's approaching the x-axis, but this area is always increasing. And this area is always decreasing because this area is always negative. At this point, we're equal, positive area, negative area, or at 0 we have no area. So our area function is going to do something like this. It's going to keep increasing. And then here it's going to keep decreasing. Something roughly to that. Okay, I think that should be good to get you started on the homework in the back of your packet. And then maybe we will hopefully have time to do this in class next week. That's all.